He's like, it's so close. Just go.
Okay, we didn't do this one, right? I don't.
No, we were getting close to it.
All right, here we go. Here we go. Here we go. Okay, implicit differentiation. Yeah, we had just talked about this, but didn't really start it, did we? Okay. So we're just going to differentiate with respect to x all the way through, because we're trying to find dy dx. And so this is what's telling us that's the variable of differentiation, right? That's telling us what we're taking derivatives with respect to, okay? So if we do this, what are we getting from the first term? What are we going to do with that? And you can pull the 3 out front, or you can just group it with the x squared. Doesn't matter. Let's you know what? Just because we usually pull it out front, let's just group it with the x squared ones, just to kind of compare the two. It's fine to do that. So if we take the 3x squared as being one thing, right, and the y as being another, right? Because we got to use product rule, don't we? Everybody agree? Yeah. So I get 3x squared y prime, right? You see why it's prime?
Yeah.
Because it's x instead of t's. Okay, plus y times 6x.
The 30's in front of it too? Yeah.
Right? And that's, remember, that's if we're grouping the 3 with it. Now, you don't have to do it that way. Just showing you it really, for something like this where it's just a simple product rule, it doesn't really matter that much. Whichever way you want to do it. So that's from our first term. Now what about the second term?
4x times y prime.
Okay. 4x times 2y.
Why?
2y.
Okay.
Yeah.
Plus
So that's all I heard.
I said it wrong.
y squared times
4
equals 0. Yeah, there you go. And so we're just trying to solve for y prime then. Notice that we kind of mentioned this yesterday, but notice that when you implicitly differentiate, even though there's a lot of calculus to do, the nice thing is the y primes are always going to pop out to the first power, right? So they're really easy to isolate, capture on one side and isolate. So let's do a couple things at once. Let's put the y prime terms on one side while we're sort of cleaning things up, and we'll put the other terms on the other side. So this term stays there on the left, right? We get 3x squared y prime. This guy stays there, so what's that one going to simplify to?
It's going to be
Oh, okay.
8.
Okay, good. Plus 8x y prime. Good. Equals, and then all the other stuff goes over here. So this one's going to be
6
minus 4y squared. Come on.
good. And so then we'll just factor that y prime out of the left side, right? And divide by whatever's left over.
Yeah.
The remains of the factoring, right?
Absolutely, we will.
Okay, so if we can do that all in one step then,
Oh, I did that.
y prime on the left is going to equal, we got this stuff over here in the numerator. And this y prime is going to be multiplied by the factor that's left over. We'll just divide both sides by that. So it ends up over here. Oops. Oh, what's that?
God.
Why it does that? 3x squared. So there's our answer. Okay? Make sense? And there's really nothing else we can conveniently do with that. Let's see. Here's the form that they had the answer in. Yeah, same thing.
Right?
Questions?
None.
Okay.
No, sir.
Okay, same kind of thing.
Oh,
Only
I like
difference
these.
here is just that we've got Yeah, we just got some trig functions in there.
Oh,
but-
trig functions do me dirty.
Let's zip through this one real quick. So if I differentiate, once again, the y is tied up inside the tangent, so we don't really want to try to solve for y. We'll just differentiate. What's the first term give us? We differentiate with respect to x. 1 minus, and then we're gonna get a bunch of stuff, right?
Yeah. Oh, yeah.
Secant
Yeah,
squared.
okay, so that's gonna be a chain rule deal.
Yeah.
Good. So what's the outermost layer of that?
So we
The
see-
tan.
Tangent. Good. So the derivative of tangent hand is
Secant squared hand.
okay
We
times
got a product rule.
the derivative of hand.
Supposed to be 1.
Yeah, so the derivative of x times y, that's product, right? So then we've got
Bye-bye.
x
Jeez.
Y prime
y prime plus
y.
y times the derivative of x is 1, right? Equals
0.
0. Okay, so I guess we don't even really, we'll dispense with, dispense with this guy, we don't really need him, do we? Okay, so now you gotta be a little bit careful with this. When I solve for y prime, talk me through that, what's going on?
You have to distribute.
Okay, I could distribute. I could distribute the secant squared xy.
Yeah.
That's fair. I don't have to. What else could I do? I could, couldn't I? Because I've got this other term over here. I could subtract 1 to this side, or even better yet, why make both, if I do that, if I subtract the 1 to this side, I'm gonna get a negative something on this side and a negative 1 on this side. Isn't it easier just to add this big term to the other side?
Mhm.
Right, which just puts the equal sign in the middle. Everybody see that?
Yeah.
Okay, and then while we're at it, really, if A equals B, B equals A, right? So let's just flip it around. So this thing ends up over here and the 1 ends up over here. That's a lot of stuff to do, but I really think this helps to kind of do this stuff in your head a little bit. Does that make sense, what I just said?
No.
Okay, so here's what
I'm
we're
not
doing.
seeing it.
We're taking
See,
the,
I understand what I would do.
we're gonna take this guy and we're gonna add him over to the other side. So
Okay.
he ends up over here. So we end up with
Oh, yeah,
to
to
be
get a
a
positive.
positive,
I
yes.
see. Okay, yeah.
that,
Okay.
and then we'll just flip them.
Okay.
Okay?
Okay. Yeah.
Make sense?
I see. I got you now.
Okay.
Just so that. Oh.
So we end up with
What?
secant squared xy times the quantity x, oops, oh. Y prime plus y equals positive 1, right? Okay, now, we could, and I don't mean to say it's not okay to do, we could certainly distribute that secant squared, but if I divide both sides by secant squared, that's okay to do, because secant is the reciprocal of cosine, right? So 1 over secant must be
What
What would you do with the 1 minus right there?
okay. So what we did is we just added this whole big term to this side,
Okay.
and then just flipped them to put it conveniently on the left. So we always we have sort of a bias. It's nice to have the variables on the left, but it's not a big deal. It's really not. So we'll divide both sides through by secant squared xy. So those factors cancel, right? And then that gives me x y prime plus y equals, what did we say that is? 1 over secant squared something is
Cosine squared.
cosine squared. That's looking a little better. Yeah, just subtract y and divide by x and we're done, right?
Bless you.
Thank you.
Just like that. Is it still snowing out there?
Yeah, it's
pretty
still
bad.
hard.
Good. Okay, so, that was
Guarantee it's it's gonna get mucho frio.
okay, so,
Hace mucho frio.
so I'm gonna recommend we just skip this one, being as we just did a harder trig one.
Yeah.
Is that okay?
No.
Okay, if we have time, we'll come back, but I think,
We're good. It's
I
okay.
think that's one we can, I wanted to get to these.
Oh, that looks dirty.
Okay, so
That looks
given-
dirty.
the given point is on the curve, find the lines that are tangent and normal to the
Oh,
curve
God.
of, right here. And when we say a curve, it just means, that's just kinda means a graph. This is undoubtedly not a function, but it's something that can be graphed, and so we call it a curve. Say it again? Exactly, yeah, so we need, if we wanna find lines, all we need to find the equation of a line is a point and a slope. Well, this is the point right here, isn't it? This point is on this
It
curve.
is indeed.
We're trying to find the normal line and the tangent line to the curve at that point. So we got the point, we just need slopes, right? Okay, good.
Perpendicular.
Normal means perpendicular to a tangent, okay? So, it's an important concept because a lot of times, like when you guys get on, you get to do some really cool stuff next year. I mean, you're doing some cool stuff this year, but it even gets better next year. We're gonna get to, or you're gonna get to where you can, instead of just looking at curves, you can actually look at surfaces. And so if you're looking at a surface, it's like, well, it's a topological feature. I mean, it's got, it's like a mountain range, it's look like a topographical map. And so when you're looking at normals there, you can actually have a whole plane that's tangent to a surface, right? Does that make sense? So it's like balancing a board on a surface. But the normal line is gonna be that one line that's perpendicular to the board that's balancing on the surface. You can kind of just picture that in your head a little bit. So these are words that are gonna pop up a lot in your futures. You're just getting introduced to them, but the idea, this idea, you're gonna build steam with this next year a lot. So we just need to take a derivative, don't we? Now, the nice thing about this is we're gonna differentiate implicitly, which is fine, but we always expect when we differentiate implicitly, if we go back here and just look at what our past triumphs, we get x's and y's in our answer typically, don't we?
Mhm.
That's okay. That's okay to do, as long as we know the x and y coordinates of the point of tangency, which they gave us, right? Okay, so we're okay. We can just differentiate this implicitly and then use those values to find the slope, right? So, and this actually doesn't look like it's really that hard of one. I mean, it's just gonna be, there's only one product rule in the whole thing. So it's really not gonna be that big a deal. First term, if we differentiate, gives us
6x.
good, plus here's our product rule. So let's just group the 7 with the x. So we get 7x
My front end.
y prime plus y times 7, good, plus next term.
14y.
Everybody see that? That actually is a chain rule deal. Right, derivative of something squared is 2 times something, but then the derivative of the something, in this case, is a y prime. Plus 18 y prime, 0 equals
0.
okay, so there's our answer. Now we can, really, if we're just trying to find, what are our options here? You tell me. Okay, we could solve for y prime explicitly. That's fine to do. What else could we do? Potentially, yeah. There might be something to combine. I don't know, it doesn't look like there really are any. But being as we're just trying to find a numerical value of the slope, it never really asks us, nor do we need to have the derivative function here, right? Yeah, we can just plug in the numbers, right? Because all we're trying to do is just solve for y prime. So we could plug in the values of x and y, which just makes this thing easier to simplify then, right? Okay.
All the y's are gonna be 0.
Yes, the y's go to 0, and so that's gonna make a lot of stuff go away. You see my point? Why go through all the hassle of doing all the algebra if we don't really need that function? All we need is just the value of y prime. So if we plug -1 in for x and 0 in for y, this term becomes this one. -7 y prime.
Yeah, I mean.
0. Did everybody see that?
Yep.
That's going to 0 because it's got a y in it.
That's 0, 0.
That's going to 0.
And 0.
No.
Okay,
We're close.
so that's
Okay.
pretty easy to solve then, isn't it?
Yep.
I mean, we get -7y prime plus 18y prime is 11y prime, and if I add 6 to that
Slick
side.
Bitty coming up close.
So y prime just equals, so there's our slope, right? Now that's the slope of the tangent line, right? We got our point, so there you go, good, perfect. So slope of the tangent line is 6/11. Does that make sense? Okay, do we need to go any further?
No, that's good. Unless you
We good with that?
Yeah.
Everybody can calculate the
And
line?
then you do the y equals m. Yeah, I got it.
Once you get the slopes?
That line's perpendicular, right?
Yes. Yeah. Okay, here's another symbol for you. This is, we got slope of the tangent line. This is just a perpendicular sign. Okay. Yep.
Are we doing a y prime instead of like
That
x
M-
prime
oh.
because it's y equals something for the equation?
Okay.
Like why don't we do an x prime?
Okay, because if we're differentiating with respect to x,
Okay.
dx, x prime is just 1, because it's just dx. See what I'm saying? It's because when we differentiate, we have y's different than x, so dy, dx, those don't cancel.
Yes, it is.
That's-
Good example.
Now, if we were doing, we could just as easily, we don't do it this way, but we could just as easily say, let's differentiate with respect to y. And then the y primes would be 1, and the x primes would be dx, dy.
No.
Yep, it's just because we typically, we think of slope as being rise over run, so dy over dx. Yeah. Okay, here we go.
Shit flexing my leg. Just kidding.
All right, how about this guy? Take a look at him. These are, this is one of the other ones I really wanted to get to. It's because we got a second derivative here. So let's take a look at how we deal with second derivatives. Because this is something, this is another issue that blossoms later, and you do a lot of stuff like this. When you take differential equations classes, you do a lot of this stuff. So first we got to find dy dx. Well, that's no big deal. We're just going to implicitly differentiate, right? So first term gives us
10x.
second term.
2y.
2y prime. 0. Or be challenged.
Okay, good. So we could move. I'm gonna kind of talk about this. Hopefully this makes sense. I'm just gonna make a lateral move over here where I'm not gonna do any more differentiation. I'm just gonna solve for y prime.
Oh yeah.
Right. So we're just doing this. We could just say if I isolate the y prime, I'm gonna get. Well, it's like adding that stuff to this side, and I divide everything by 2y. So I just get what, 5x over y. Everybody agree with that?
I do see that. See.
Okay, so now here's the question. Right, here's the question. We've got y prime explicitly isolated here. Do we take the second derivative starting with the blue or starting over here?
Starting
Over there.
I'd say starting on the left, absolutely.
Because that was.
Because you don't have a quotient rule to deal with then, do you? Right. Now, one thing we could do, we could simplify that a little bit, couldn't we?
Yeah.
What can we do? Yeah, we could divide both sides by 2 and make the numbers a little bit smaller. So we get, and while we're at it, why not, I don't want to complicate things too much, but why not just factor out a -2, divide by -2, or multiply both sides by negative, so we just change the signs,
Down.
right? So we end up with y prime minus 5x equals 0. Pause there, is everybody okay with that?
Yep.
Okay, just to kind of set ourselves up to have a little bit easier algebra.
Fair enough.
Okay, and now we'll just continue, we'll just differentiate again. So if we differentiate again, so I do have a product rule for this first part. So what's that gonna be? Ah, yeah, okay, the first times the derivative of the second is y. Ah, good, okay, derivative of y prime is y double prime, that's our second derivative. Y prime prime, y double.
Minus 5.
Plus the second
We got a product.
times the derivative of the first.
Prime.
So that's y prime times y prime,
Squared?
y prime squared,
Oh.
right?
Sounds like pot pie.
I don't like
This makes no sense.
Everybody okay so far?
Mm-hmm.
You're
Okay,
losing me.
question?
I really don't have a question. It's just-
Okay, well, before we move on, let's take a second look at that.
Now, walk me through
Okay,
this.
let's make sure everybody's okay with that. Walk it through apart. Okay, I got a product there, right? So we got each product rule. First times derivative of the second
Okay,
plus second
okay,
times derivative of the first.
okay.
See what I'm saying? So that's y prime times,
Because
Y
y
prime.
would be y prime, and then they multiply together.
so it's
Oh,
y
okay.
prime squared, aha, okay, good, all right, all right.
You got it.
Okay,
So now this is fire.
minus 5
Yeah.
equals 0, okay.
Feature.
So then if I solve for, we already got y prime up here, right? Now if I want to solve for y double prime, isolate y double prime, I'm just gonna subtract all this stuff to the other side,
Mm-hmm.
right? And then divide by y?
Yeah.
Okay, so,
That's just
This is y prime.
Five.
Minus all over 1.
okay, so that's my answer. Problem is, we don't really want to have the second derivative written in terms of x's and y's and the first
Yep.
derivative.
Substitute. Substitute.
So you could put that,
It's dirty.
More work. Square it now?
I just like more
See what we're doing?
Mhm.
Okay, every place we end up with a y prime in our answer, right, in our answer for y double prime, we're gonna substitute the expression for y prime that we previously got, right? So, that makes things ugly, I suppose.
No. Good luck. Math is math. Science is science.
Over y squared over 5.
Yeah, I guess you can count, yeah, I guess you can count that.
Yeah, exactly. Okay, so this isn't that big a deal. All we gotta do is, if we square this out, we're just gonna get a, remember what our general strategy is, and this is important. When we're dealing with a rational function like this, where we got stuff on the top and stuff on the bottom, our goal is always to turn the numerator into one big fraction, denominator into one big fraction, then flip and multiply by the bottom, right?
Mm-hmm.
So on the top then, if I square this out, I'm just gonna get, what, 25x squared over y squared? Okay, so 5 minus 25x squared over y squared. Well, what's my common denominator need to be on the top? Y squared, right? So I can just multiply this guy by y squared over y squared? Okay, good, so 5
It's still on the bottom.
y squared over y squared, that's my numerator over all over y over 1, right? So let's write the top with a common denominator. So that's 5y squared minus 25x squared over y squared, everybody agree? Times the reciprocal of the bottom, right? So if I multiply straight across, then I'm just gonna get a y cubed on the bottom?
Yes.
Yo, where did you get the y squared on the bottom?
Because it's the y squared that was
Oh,
on
okay.
the, yeah.
Start walking to school. It's all the way from the
Right? Okay, does that make sense? Leighton, see what we did? We flipped and
Yeah.
multiplied?
Yeah, I get it.
Okay, and so then we just end up with, and I could factor a 5 out, I guess, if I want to. So there's my second derivative in terms of x's and y's. It's a lot of algebra, isn't it? I mean, really, wouldn't you say even at this point, calculus is about 85% algebra?
Yeah.
Hard algebra, but just algebra. You're gonna be really good at algebra at the end of the year.
Yay.
Okay.
I thought it was already.
There it is.
algebra. Guess not.
We got it. How about that?
Oh, no.
Okay, what about this guy? Okay, so this is kind of this is a good one. This is actually, this doesn't look that complicated, but I would say this is one of the harder related rates problems.
It doesn't look that bad.
Doesn't look that terrible. So find the rate of change of the distance between the origin and a moving point on this graph. So now think what this is saying. You gotta kind of wrap your brain around this first of all. So we've got, this is a really cool problem though. This is a good one. So I've got this function. This is just a parabola that's hoisted up by 1, isn't it?
Yes, that's
Right, so
correct.
we got,
I'm gonna draw this.
not that that's really important, but if a point is moving along, it's a bead moving along that wire, excuse me, now what does this imply here? If dx dt equals 2, what does that mean? Okay, so what does that mean in terms of our picture of the bead sliding along the wire? What is, how fast it's going? Okay, in the x direction, so that's really just the x component. Remember that stuff we talked about yesterday? That wacky stuff I was talking to you about with the projectile motion?
Oh,
That's kind of what we're dealing with here, isn't it? This is really just, in physics, you'll get into this soon. You're gonna go, oh wow, I remember, we've seen the calculus of this. This is just the x component of the motion, right? So if velocity is ds dt, you physics types, right, where s is position, really that ds dt is just a vector composition. So that's gonna be, in the x direction, it's dx dt, and in the y direction, it's dy dt, right? So those are the two different aspects, or two different components of that motion. So seen from above, this bead is going to be moving at constant velocity in the x direction. Now, what does that imply about the overall speed of that bead? If it's going to be moving horizontally, like from left to right, so that its x component is always moving at the same speed, what's that tell you about the y component? It's not going to be constant, and what's it going to be doing?
Speed up.
It's going to be speeding up quite a bit, isn't it? If it's going to be covering, let's pretend these units are just like centimeters and seconds. If every centimeter it's moving 2 seconds to the right, well, when this thing starts to get pretty steep, it's flying up there, isn't it? It's picking up speed pretty fast in order to do that, isn't it? Right?
Oh, yeah.
I mean, that's not that we probably need to know all that stuff, but I do think it helps to try to kind of get a picture or get a feel for what this situation is like when you're doing the calculus. So, okay, so we want to then find the rate of change of the distance, right? So here's our bead. We make our bead red so it sticks out. The distance between the bead and the origin, right? That's just going to be that right there. Okay, that's D. What's my equation for D? Really, isn't this just a right triangle? It's just hypotenuse of a right triangle. Okay, it's probably bad colors, but my red doesn't really stick out there. There's my red bead. What are the coordinates of the bead? We don't know for sure, but just in general, they're X and Y,
Oh, yeah.
right? Okay, if we say that the coordinates here are X and Y, then that's just X, isn't it? And that's Y in that right triangle. And so the hypotenuse is going to change, but what is the hypotenuse in terms of X and Y? If it's a right triangle. Square root of X squared plus Y squared, right? Okay, so we know that the distance D, which is really what we're looking for, D equals the square root of X squared plus Y squared. And so that's kind of what we're saddled with here when we differentiate. But we're told something here. it's not like this bead is just, can be any place in the plane, it's just floating around in two-dimensional space. It is constrained, isn't it? Isn't its motion constrained? What does constrained mean? That's a really important math word, calculus word. It's limited, yeah. It can only move along a certain path. So, and just, I mean, this is like a light bulb moment here. This is kind of cool. If we know that its motion is constrained, so it's moving along this path, then that means there must be some kind of a connection between the x's and y's that we can exploit. Well, there is, isn't there? See what I'm saying? If x and y, if the motion is constrained like that, then that tells us that the y's are always related to the x's by that equation. And so we could really rename this point if we wanted to. Instead of calling it x, y, we know that y is really just equal to x squared plus 1.
That's clever.
See what I'm saying? And so when we go down here to write our distance formula, instead of plugging in a y, we could just plug in the quantity x squared plus 1 squared. Because the y is always going to be dependent on the x, because we're following this specific path with our bead. Right? That's good. Now, that's kind of what's, now algebraically, what have we done? If we had to sort of couch what I just said in algebraic terms, we would say, well, this is a secondary equation, and so we've used this secondary equation to eliminate a variable. But see how the algebra really just, I mean, it's just two ways of saying the same thing. So if we make this substitution then, and I guess we would probably put a box around our substitution equation and substitute, we end up with d equals the square root of x squared plus y is just the quantity x squared plus 1 squared. And so I can clean that up. I can just square that out and add up like terms. And the advantage there is now we end up with our distance that we're trying to find the rate of change of distance, just d dot, right? Distance is written in terms of a single variable x. Okay? Does that make sense?
Mm-hmm.
Okay. So let's do this. So what is x squared plus 1 quantity squared?
Bless you.
Okay.
X to the 4th.
X to the 4th plus, well, no,
2x squared.
2x squared plus 1, but then plus another x squared is plus 3x squared plus 1. So if we want to differentiate this, we'll probably write that as what? If I want to differentiate this whole thing, what do I have to do with the radical?
Oh, 1/2.
1/2 power. Okay. Okay, so now we can go ahead and calculate d dot, right? We got our parent equation, right? Does that make sense?
Yep.
That's our parent equation. We'll differentiate. So what do we get if we differentiate this? What's the first step going to be here?
1/2.
Okay, good. Did everybody see that? We've got hand to the 1/2, don't we?
Mm-hmm.
So we get d dot is just going to be 1/2 times hand to the,
Negative 1/2.
good, and we'll fill in the blanks. And now we got to look inside and take the derivative of hand.
Whatever happened to the x squared?
We added to the other.
We just added that x squared into the
The 2x squared.
like terms. When we FOIL that out, we get x to the 4th plus 2x squared plus 1.
okay.
We'll just feed it into there.
Alright, yep, okay, never mind, sorry.
So the derivative of hand then is what?
4x cubed.
6.
Okay, but we're differentiating with respect to
Oh.
t,
X
right?
dot.
X dot. Oh, that's dirty.
Plus
6x.
good. Okay. Good. Okay, so we got it. Now, do they tell us x here? They just tell us x dot. Okay. Find the rate of change of the distance between the origin and a moving point on the graph. Okay, so our answer is going to have x's in it then, right? Because they never told us, and we can't calculate it, can we? We don't know. We don't know what x is here. Okay.
You can always guess.
You can always guess.
Just guess. So then our answer is going to look like, if I write this, I can make the x dots into 2's, right? That's all we know. But the x's are still going to be stuck in there. And that makes sense because, well, we end up, think about what we're getting here. We're getting, because they don't give us x, we're finding d dot as a function of x. So we could say, okay, after the fact, we could say, what's it going to be when x is 10? What's it going to be when x is 0? And we can substitute those in and get all the answers we need. So this is a square root on the bottom.
Yeah.
Right, so we get, we're running out of space here. So on the bottom, we get our 2 times the square root of x to the 4th plus 3x squared plus 1. What are we left with on the top? It looks like 4 times 2 is going in for the x dots. So good, 8x cubed plus 12x, good. And I could cancel a 2 top and bottom, and that's about all I could do. So we get 4x cubed plus 6x over our square root. That's it. So that's d dot as a function of x. Now, if they had given us an x, we could have plugged that in too. But they didn't. Okay. Make sense?
Yeah.
That's a doozy.
That's a good one.
Okay, so how much time we got?
6 minutes.
6 minutes. Man, I want to do another related rates one.
I'm okay with the related rate. Let's do a related rate.
Are there any, okay, pick one. Yeah, if you could pick one related rates problem from the assignment, which one would it be?
One
Cone?
related rate.
The cone's a good one, yeah. Okay, let's do the cone.
Which one's the cone?
The cone where the gravel's falling, or the sand or the gravel or something's falling onto the conical pile.
Okay.
That's a good one.
I didn't get that one.
Oh, we gotta know that, I agree.
Yeah, we should just take this on Thursday.
Oh, man, I don't know about that.
Well, I mean, because then we could all get extra practice. So I think it's all included.
Okay, so let's.
Dude. Okay, I was just thinking that we were going to correct our vocab test, so I didn't know if it was all. And I was like, oh, okay. I just wrote it. You got a 7+.
Are you serious?
Yeah.
I was like switched out that whole entire time.
I was like, oh, I don't want to be here.
That's the best thing I was like, Thanksgiving, turkey, Thanksgiving.
Yeah.
This guy, right?
Yes.
Maybe. That's the one.
That is filthy.
Yes.
Oh, jeez.
That's the one we want. Okay, we're not going to probably get through the whole thing, but we'll just get through what we can. We'll get a start. Where is it? Oh, you kidding me? Okay. Okay, so let's at least just get a little start on this. Okay, so the picture we want. Two-dimensional picture is sufficient here. In fact, it's really what we want, isn't it? We'll just take a cross section through the middle of the pile, right? So then we end up with, here's our pile. I'm not so artistic. I don't need to be for that picture. Okay, now they tell us some stuff here. What is? Let's write down our snapshot variables, snapshot values. So what is that?
That looks like change
Rate of change of
Area.
no
no
volume. Okay, how do you know?
Good job.
Ah, good. Okay. Remember, you look at the units. When you're trying to figure out what's given to you, the units are dead giveaways. If the units are cubic meters per minute, cubic meters is definitely a unit of volume, right? Meter or minutes, unit of time. So that's V dot, isn't it? So we're given V dot equals positive 9. They tell us one other thing here. Okay, how high it is. So we'll call that H. Okay. So when the pile is 2 meters high, so that's going to be height. Then the other critical, if we look at this picture, this is height, right? What's the other, if we're going to come up with a parent equation for volume, do you know what it is for a right circular cone?
No.
1/3 pi r squared h. So we're going to need the h also. I mean the r also. So there's our radius, right? Okay, so let's write that down. And I would give that to you. If you ever, like on the test, I don't expect you to memorize all those geometrical formulas. If you don't, and I don't know why they're not on here. It seems like they should be. I will give any of those formulas to you that you need. I'll write them on the board. Or so just, okay, that's not a big deal. I don't care if you memorize them. Okay, so they want to know how fast are the height and the radius changing when the pile is 2 meters high. But they give us something important here.
I was always say
I think we're about out of time. What about this?
Oh.
Okay, yeah. Okay, so look what we're able to do here. Now, we can make life a little bit easier because if we differentiate, here's our parent equation, right? If I differentiate this, I'm going to get a product out of this too, right?
Yeah.
Okay, if I could come up with a secondary equation that related the two independent variables, an equation that related the r and the h, I could substitute for one in terms of the other and eliminate a variable, right? That'd be helpful. Here it is. If we know the height of the pile is always 3/8 of the base diameter, isn't that just saying h equals 3/8 times the diameter is really 2r? Does that make sense? And so I can solve then for h in terms of r, or vice versa. It doesn't matter. I can isolate either of those variables in terms of the other, and we'll pick it up later. And
So this sounds like tests on Tuesday.
how about, what do you got? Okay, let's make a decision on the test. You want it?